In our previous session, we had discussed about the airfoil graph analysis. Now let us start off with the wing design. Wing design, first click on file and select the wing and plane design. Here we can do 3D analysis of main wing, tail wing, fuselage and aircraft as a whole. Click on the plane, select define a new plane. We have the plane editor screen opening. This is a default window. Now we can define the main wing, elevator and the fin platform here. But to define the main wing, let us first deselect the elevator and the fin. Now we have the plane description here where we have to select the name of your aircraft. Now under the main wing, once we click on the main wing in our previous window, we have the wing edition opening here. We have to click on define and then only this window will open. This is also a default screen. So here we have section 1, that is near wing center. Section 2 is near the wingtip of the wing. Then Y is the half wing span. Chord is the length from the leading edge to the trailing edge. Offset is the wing angle shift from Y axis. Dihedral is the angle between the two intersecting half wings. Twist is the chord line changes angle from tip to root without changing the airfoil. Choose the airfoil already analyzed. So here we'll be using 2412 airfoil. The panel X and Y distance for meshing. More panels, more accurate the reading will be. So we'll have Y in meters. Then we have the chord in meters. And then we have the offset in degree. Twist in degree. The foil will be 2412. Let us look into the filling details. So our Y in section 1 will be 0 meters, Y in section 2 will be 0.472 meters. The chord in section 1 will be 0.188 meters. The chord in section 2 will be 0.188 meters because it's a rectangular wing. The offset, dihedral and the twist will be 0 and the foil will be NACA 2412. We can also select the texture and choose the color of the wing. And now we can click on the save and close. And then we can click OK on the editor screen for that window also to close up. The main wing design result will be like this. Now the main wing design analysis can be done. For that we have to click on analysis and then define an analysis. Here we have the polar type as select type 1, which is for fixed speed, and the free stream speed is 15 meters per second. So under analysis, we have analysis method, that is horseshoe method vortex, and the option should be viscous. Then we have the inertia, which is unchanged, and reference dimensions, which is again unchanged. It can be wing plane form projection projected on XY plane. Then under aero data, we have density as 1.225 kg per meter cube, kinematic viscosity as 1.5 e to the power minus 5 meter square per second, and extra drag remains same. And then we can click on OK. The main wing design analysis result will be like this. Once we are done with this, we can click on the analysis settings, start and end alpha, selecting start alpha as 20 degrees or end alpha at minus 20 degrees. We can click on the analysis, and under the results we can select the parameters to analyze, like lift, CP, induced drag, moment or viscous drag or downwash. It can also be animated. The lift and drag on the main wing can be analyzed for all the angle of attack like this. So that is the drag of an aircraft wing. We can see the alpha changing here. Minus 1, 0, 1, 2, 3 degrees. and simultaneously we can see the CL also here on the bottom right side. That is possible by clicking on the animate button in the results under the results section. So not only lift and drag can be seen, but you can also select the other parameters under the result to view at different angle of attack and different distribution on different surface of wing. So let us do this in the XFLR software. This is where we had stopped in our previous session. So let me continue. Click on File, select Wing and Plane Design. Click on 3D view. We'll get this X, Y and Z coordinate. Now click on Plane, define new plane. This is the plane editor. So let us deselect the elevator and fin for now and define the main wing. This is the wing addition. We have Y, chord, offset, dihedral, twist and foil. So we have section 2 as 0.47218, chord in section 1 and section 2 as 188, offset 0, dihedral 0, and then we have foil, NACA 2412, offset has to be 0 in both the sections. Hence we get this rectangular wing. We can change the texture here or choose any other color by clicking on the color option. So let us stick to the texture for now and save and close. Click on OK. So this is the rectangular wing that we have got. Now let us start off with the analysis. Define analysis. Fixed wing, we have 15 meter per second. Analysis, horseshoe vertex, inertia, unchanged, reference dimension, wing planform projected on X and Y plane, aero data and extra drag unchanged. OK. Now start -15 degree and 20 degree, analyze. OK, close. Now we can see we have lift for 10 degrees and we can check the induced drag for the same. The animate button, this is how it works. You can increase the speed up to your convenience. And not only this, you can check momentum, viscous drag and downwash on the same airfoil too. This is the Y view, this is the X view, this is the ISO view and Z view of the wing. So now we are done with the wing. Let us move on to the empennage design in the next session. Thank you.